today's lecture we shall have a look at what is the tiling algorithm. Now please note that tiling algorithm is basically a network growing algorithm like the other network growing algorithms which we have already seen, that is Markand algorithm and neural tree algorithm. So what we need to note here is that it is a network growing algorithm. So we will be starting with a small network and then we would be going on to get a bigger network, that is a network of optimal size. Now, so the tiling algorithm creates a strictly feed forward network. So we know what is a feed forward network, that is we start from the lower layer. Okay, this is the one layer and then we have another layer. So this is a feed forward network. Basically somewhat like this would be a feed forward network. So it would be going from the inputs, from the input layer to the hidden layer to the output layer, and finally the output layer will produce the final output. So basically there will be connections which will be existing from this layer to the next layer and from this layer to the next layer. So it is said that connection exists from each layer only to the immediately succeeding layer. So no connections from the first layer to the last layer, no. The connections will be from the first layer to the second and the second layer to the third, like this. Next, now with each new layer, now how are these layers added? So first, whenever we begin, we will be beginning with the first layer only, and then successively the nodes will be added. So first, in this case, we would be beginning with one particular node. So we begin with one particular node and then we would go on adding more and more nodes in that particular layer. So within each new layer, nodes are successively added until every pair of samples of different classes can be differentiated by some node. So this is one node which we have begun with. So I'll draw it again. So we have one node. So the first node is drawn. Then I go on adding the nodes in the layer. Now this first node which is drawn, I call it as the master node, and then the other nodes will be called as ancillary nodes. So I go on adding the nodes in the layer such that they will be performing some classification task. So every pair of sample of the different classes should be differentiated. For example, let us take the simple XOR problem. Okay, if at all we take the simple XOR problem. Now first we select a particular node which will be, now it is not possible for us to have a, if at all it is some other problem like this, then I can have one particular line and this line will be separating the patterns from class 1 and class 2. But in case of an XOR problem, it is a non-linear separable problem wherein it is not possible for me to separate these patterns from class 1 and class 2. It is not possible for me to separate the patterns from class 1 and class 2. I made a mistake here. Just by using one line. So what I have to do is that I have to start with one particular node which will give me the minimum number of misclassifications. So now if at all I have drawn this particular line, there is only one misclassification. This is your class 1. Class 1 is nothing but X, and this is your class 2 which is nothing but of O, and only one of them is misclassified. Now which one? This one will be misclassified. So this one, the first line which I have drawn here, this one would give me my master node M, and then still the classification is not done. I have to draw one more line here so that I can separate this X which was misclassified in the previous one. So that would be the ancillary node A. And then, so basically I have to connect these two nodes to the second level master node. So if this is master 1, this is master 2, and this will be producing the output. So this is the basic idea of how you would be solving this type of problems. Now I have taken the example of XOR gate. I would just extend the example. Okay. Now in this case, if at all, I would like to, before that, I would like to explain. See here, what happens is that I would just repeat this. Supposing I name these patterns, so I would like to name these patterns as say A, B, C and D. So whenever we select a particular line, now first we selected a line here. So first, before that, we have to write the pairs from class 1 and class 2. So we have in class 1, we have patterns A and D, and in class 2, we have patterns B and C. So now I am writing the pairs. Now how I will form the pairs? I will form the pairs like this. One pattern from class 1, other pattern from class 2. One pattern from class 1, other pattern from class 2. Then I go to the next pattern from class 1, and finally I get 4 pairs like this. Okay. Now whenever I have drawn my first line, which is I have indicated as M1 here, corresponding to this node. What I have achieved is that I have to check which separation I have achieved. Have I been able to separate A and B? Have I been able to separate A and B? No. There is no separation between A and B here. So I have not been able to separate. Have I been able to separate A and C? I have not been able to separate A and C also. Have I been able to separate D and B? Yes. D and B, I have separated them by using this particular line. So I have been successful in separating. So what I would do is that I would cancel this pair. Similarly, D and C also I have been able to separate it by this line. So I cancel. So whenever I select the first node, I have been able to cancel out these 2 pairs. Now the other 2 pairs are left, A, B and A, C. So my next node, which is the ancillary node, should be selected in such a way that that classification will take place. So I select a line here such that these 2 pairs AC is also separated and AB is also separated. So this is the simple example of a tiling algorithm. And then finally you need to have one more node which would be separating the 2 different classes. Now basically here I will have class 1, this will be class 1 region, this middle will be class 2 region, and again there will be class 1 region, right? So this is also class 1 region. So I have to ensure this M2 will ensure that it separates both these regions, meaning there are 2 regions of class 1 and 1 region of class 2. So I should ensure that both the class 2 regions will produce the same output. So that would be done by this second master node. Is that clear? So this is the basic idea about the tiling algorithm. Now I would simply like to extend the same thing to one more. Say for example, if at all I have a pattern like this. Okay, so I can name this, okay, for simplicity I will name this as ABC and this as 1, 2, 3. So how many patterns I will have? I will have in class 1, I have the patterns A, B, C, and in class 2, I have the patterns 1, 2, 3. So what I would be doing here is that I would be having the pairs, okay, and which are the pairs I can connect the pairs. So I can write A1, A2, A3. Similarly, I can have B1, B2 and B3. So basically I am from here only I am going to form the pairs. One pattern from class 1, one pattern from class 2. So I have C1, C2 and C3. Now whenever I draw the line now in order to separate this, now whenever I go to the problem, basically what is tiling algorithm is, I will draw a line such that there will be minimum number of misclassifications. So I have selected to draw a line here. This will be my master node. So what happens is that this is say class 1 and this side is class 2. The other side is class 2. So other side I have one. Class 2 means what? Class 2 means it is of the circles. Okay. So class 2, basically here, if I check the number of misclassifications, how many misclassifications do I have? Here I have one misclassification, here I have one misclassification. So I have only 2 misclassifications, minimum number of misclassifications are there. So I have selected this line as the first line. So the first line has to be selected such that there will be minimum number of misclassification. This is what is very important. The first line has to be selected such that there are going to be minimum number of misclassifications. For this you can use what is called as pocket algorithm. Okay, so here we will not be using pocket algorithm, we will be just checking which is giving us the minimum number of misclassifications. Otherwise, in real life, whenever you are using this tiling algorithm, before that you have to use the pocket algorithm to find the minimum number of misclassifications. Now once you get the minimum number of misclassifications, now you see that you have drawn the line and you see which are the pairs getting separated. Now is A1 pair getting separated? Is this pair getting separated? No. Is A2 getting separated? No. What about A3? A3 pair is getting separated, so I cancel it out. What about B1? B1 pair is getting separated, I cancel it out. B2 pair is getting separated, I cancel it out because there is a line separating them. What about B3? B3 is not getting separated because there is no line here. Fine. What about C1? C1 is getting separated and C2 is getting separated as well. Okay. So I have shown which are the ones which are getting cancelled, which are the ones which will remain. Now in order to separate the ones which will remain, we have to again draw the ancillary nodes. So I have got the first node, that is I have got the master node corresponding to this particular line which I have drawn here. So I will get the master node. So I draw the master node M1. Okay, and then I need to add the ancillary nodes to the network. Now ancillary nodes, how you will be adding is that you have to separate now this one which is misclassified, right? So again this side is class 1. So I am drawing this ancillary node A1. Now when I draw this ancillary node, what is getting separated is the link between B and 3 goes and C and 3 goes, because there is a line which is come to separate this. So B3 and C3 get separated. Now what is remaining? A1 and A2. So for that I will be drawing another node. So for that I will be drawing another line like this, and this side will be class 1 because you can see the direction of class 1. I have taken in the direction of class 1 as positive. So this node will come here, A2. Is that clear? So this one will separate A1 and A2. And finally I connect this to a master node M2, and then finally I will be getting the network. Now why this master node M2 is required is to ensure that, now see here, in this pattern there is how many samples, so how many clusters of pattern 2, pattern 1, class 1, there are 2. This is one pattern, this is second pattern what I have circled. Similarly, there is of class 2 one pattern and one more pattern. So now these two different patterns of class 2 should produce the same output, and these two patterns of class 1 should produce the same output. So in order to ensure that, the second layer will be added. So this is the basic idea of how to go about a tiling algorithm problem. Fine. So basically each layer is constructed in such a way that if two samples I1 and I2 belong to two different classes, then some node in the layer produces different outputs for I1 and I2. So basically this I1 and I2 are nothing but whatever pairs I took in the previous example. I have taken the pairs and I have explained to you that every pair should be separated. So I have to go on adding the nodes in such a way that all the pairs get separated, just as how I have explained to you previously. And the subsequent layers of the nodes would be capable of then distinguishing between the samples of different classes. So if at all your nodes in the first layer are not added properly, then in the second layer you will be getting a problem. In the second layer, it will not be able to properly classify the data. So that is the reason you have to ensure that in the first layer all the patterns are separable. Okay, all the patterns, all the pairs, whatever number of pairs you got, you should be able to separate them with some line or the other, some node or the other. Only then in the second layer it will be able to separate the different samples. Okay, samples meaning this is one sample of class 1, this is one sample of class 1, this is another sample of class 2, and this is another sample of class 2. So all the samples of class 1 should produce the same output, and all the samples of class 2 should produce the same output. So that would be ensured by the subsequent layers or the subsequent layers of the nodes in the neural network. Now next point is that each subsequent layer will have fewer number of nodes. As we have seen previously, as you go on to the next layer, next layer, next layer, the first layer had more number of nodes, second layer will have lesser, third layer will have lesser. So it will be until there is only one node. The final node, there will be only one node which will be providing the classification into the two classes, because this is a two-class classification problem. So final node has to be only one node. So basically once you reach one node, then you have to stop the problem. So you start with many nodes and then go on decreasing the nodes, and once you reach that one node is present in the final, one node is present, then you know you have to stop the algorithm. So basically this process of adding the nodes is called as tiling. So we are adding nodes in the given layer, right? The first layer I go on adding some nodes, then so that process is called as tiling, and because of which this algorithm is called as tiling algorithm. So basically the network development, we shall have a look at the network development using the tiling algorithm. So first the master unit is trained. This I have already told you, we have already gone through. The master unit is trained using the pocket algorithm. Okay, so the master unit, that is the first unit, will be there, and this will be to perform the best possible dichotomization, meaning the best possible, meaning minimum number of misclassification. So the first node should ensure minimum number of misclassification. So that is what we need to ensure. Now, so first we start with the first master node, as we did in the previous case also. Then the additional ancillary nodes are added. So what I did is that whatever I showed you in a vertical plane, here it is shown in the horizontal plane. I am going on adding ancillary units here. Then I add one more ancillary unit. So I added the first ancillary unit. Then I added the second ancillary units, and when I am done with the adding of the ancillary units, I go in for the second layer. Once I go in the second layer, meaning when can I go to the second layer? Once I am done with all the pair separation. So this point I am done with the pair separation, all the pairs are separated, so I go to the next layer, and then after that, if required, I can add ancillary unit in the second layer as well. And then after that is done, I can go to the final layer, the final output. And since I am getting only one node, I will be stopping at that particular point. Now, the problems which you all will get, you all will not be required to go to more than two layers. It will be mostly two layers, first layer and then maybe second layer. Not more than two layers problems, it will become complicated. So it won't be asked for all, but you all have to know the problems of at least two layers. Fine. So this is what it is, the tiling algorithm. Whatever is shown here is the progressive development of a 3-layer feed-forward network. This is 3-layer, but mostly you will have to know only 2-layer feed-forward network from problems point of view. So M means master unit, and A1, A2 and A dash are nothing but the ancillary units or the ancillary nodes. Now we shall be solving a problem in this particular case, that is we shall be solving the corner isolation problem first using the tiling algorithm.